2,
1. Hey.
All right. You guys got the best one of the day because you are the best audience. All right, and so you can see some smoking still because we didn't quite vaporize all of the liquid nitrogen, but we do have to be careful. You may notice she was wearing special gloves and things like that. It is cold enough that it actually burns, so that's why we've had to do that with it. All right, so that is actually our last demonstration for you today. So we want to say thank you so much for coming out and enjoying some science with us. If you have any questions about the demonstrations today, remember that means we're setting it on fire. Is it going? Oh, come on, get going. All right, where is it? Where's the big toy? Also, get the blowtorch. Good. Is it lit? Oh, there it's going. It's going. So it's a little hard to see because ethyl alcohol or an isopropyl alcohol very, very clean. But you may start to see some flame here. Okay. So if you look down here, the wind is causing havoc.
So windy.
But trained for it. This reaction has been around for a long time. They actually use this on the railroads to help weld the ties. Okay, so into this though, we need to get it started because it's hard to get going. So they're putting a little bit of magnesium ribbon in there. Now magnesium is a metal that burns relatively easily, not super easy, but what you're going to see is, actually don't start quite yet, is we're going to start the magnesium burning. It's going to give off a very bright white light. That light you may have seen before because that's where fireworks get their light from. That's then going to start the thermite reaction. Now I'm going to tell you what you're going to see just so you have kind of an idea what to look for. We're going to go from room temperature to 3,000 degrees Celsius in less than 1 second. And when this reaction goes, it gives off an incredible amount of energy. We're going to see some sparks coming up, so my demonstrators are going to step back. But then, that is hot enough that it can melt the iron that was part of the rust. So if you watch the bottom of the pot, you will actually see molten iron come pouring out the bottom that we have produced by a chemical reaction. All right, so let's go ahead and start this. All right, we see that bright white light like a firework? All right, it's going to take a minute. We had a long chain. Oh, it went out. Let's try one more time. Go ahead. Go ahead and light it a little lower down. There you go. Oh, there you go. All right. All right, so it's going to go down into the thermite. It's going to start this reaction, hopefully. Oh, there we go. We've got the reaction going. Watch the bottom of the pot in right about there it is. There's the molten iron pouring out of the bottom of the pot. So if you put that in front of a railroad tie or above it, right, you can do a little welding. And do we have our... I love that demo.
I love it. I love it. I love it. Cool.
It's nice and warm. I can warm myself.
You guys like gummy bears? I really like gummy bears. I'm excited about what's about to happen in these gummy bear guys. You ready? You're watching. You got a gummy bear right here. We're about to drop it in. 1, 2, 3. Screaming gummy bear. And all of that is happening inside your body right now. That's the screaming gummy bear.
Instead of the hydrogen peroxide you can buy, that's 3%. All right? So that means there's 3% of hydrogen peroxide and the rest is water. Now you can actually also buy 10%. It's really strong. That's what's used for bleaching hair. All right? And that's the most that you as a consumer can get. Boring. We get 30% hydrogen peroxide. All right? So that's what we put in here. Now, hydrogen peroxide will break down on its own to form oxygen gas and water, which is actually why it is stored in a brown bottle, because light makes that reaction go faster. So what we're going to do, though, it makes it go faster, but it still takes like several months, and that's just boring. So we want to try to speed the reaction up a little bit. So we're going to add something called a catalyst. A catalyst is a chemical compound that increases the speed of a reaction. Now this one is just a salt. It's potassium chloride. Now, if you think about potassium, that's just one right below sodium on the periodic table, so it's really close. But we're going to add it and see if we can make this reaction go a little bit faster here. So let's go ahead and do it. Let's put it in and see about, whoa, science! Ah, oh, whoops, wind. Okay. Oh my goodness. Well, our elephants are going to have very clean tusks today. So is the parking lot, but that's okay.
You guys like gummy bears? I really like gummy bears. I'm excited about what's about to happen in this gummy bear, guys. You ready? You're watching. You got a gummy bear right here. We're about to drop it in. 1, 2, 3. Screaming gummy bear. And all of that is happening inside your body right now. That's the screaming gummy bear.